1. And I got quite a few problems here that people were asking for, so it'll take a little bit here. But number 10 will be the first one. And it said this is the function, and we're supposed to try to figure out what this is telling us to do. And it says the change in x is 1/3. Well, in here I'm going to do 1 times 1/3. Then I'm going to do 2 times 1/3, and then 3 times 1/3, all the way up till 6 times 1/3. Well, 6 times 1/3 is 2. So 1 plus 2 is 3. So I'm going to end at 3, and I'm going to start at 1. So, and this looks like, so let's do a quick graph of this. If I plug 0 in here, 0 squared plus 1 is 1. The square root of 1 is 1. If I put 1 in, 1 squared is 1, plus 1 is 2, so I have the square root of 2, which is 1.4-ish. That's where I'm starting. And if I put in 2, 2 squared is 4, plus 1 is 5. Square root of 5 is 2.2 something. And if I put in 3, 3 squared is 9, plus 1 is 10. Square root of 10 is a little over 3. So we got some sort of curve going like this, and we're supposed to find the area between 1 and 3. And once again, because we're doing 6, we're going from 1 to 6, so that's 6 splits in this. Each one is 1/3 wide. So one's going to be at 1 1/3, 1 2/3, and then at 2, 2 1/3, 2 2/3, and then 3. So those are the rectangles. And since it says to start with 1 plus 1 1/3, we're doing the right hand side of each of these rectangles. So that's basically what we're doing. We're doing R6. So this formula says use 1. They're all times delta x, and delta x is 1/3. So I'm going to just put the 1/3 on the outside. And then we're going to do 1 in here. So 1 plus 1, I is being replaced with 1 times 1/3. So that's 1 plus 1/3, that's 4/3. If I put 4/3 into the equation, I get 4/3 squared plus 1 square root. That's my first right hand side height. And that's times 1/3. And then I got to add to it the right hand side of the next one. Or I'm going to put in 2. 2 times 1/3 is 2/3, plus 1 is 5/3. So then I got to put 5/3 into this equation. So I'm going to have 5/3 squared plus 1 and square root. That's what this would be, and it's going to be times the 1/3 that I've already put on the outside. Plus, and then I go one more third, so that would be 3 1/3, or 1 plus 1 is 2, so I'm going to have f of 2, which is 2 squared plus 1 square root. The next one would be 2 1/3, so that's 6 7/3 squared plus 1 square root, plus 8/3 plus squared plus 1 square root, and then finally 9/3, which is 3. And each one of these is times 1/3. So I found f of, I put each of these numbers into f. And that's what it looks like. And now it's just a matter of calculating that out. And so you you can type each one of these into the calculator, figure out each of these values, and take it times 1/3. Now I'm going to do that. I don't have my calculator here. Okay, if I had my calculator here, I'd put in a table. I'd start at 4/3 and then go 5/3, 6/3, 7/3, 8/3, 9/3. So step by a third, and then put in y1 this, and then find out what 4/3 in it, 5/3, 6/3, each one of these is. Take that total times 1/3 to get my answer. Okay, I'm not having my calculator here. It's going to be a problem. Number 12. So now we can see that each of these rectangles has a height at the midpoint of these. That's the way it was drawing. So I'm actually doing midpoint, and I got 1, 2, 3, 4, 5, 6 of them for this curve. And so that's going to be f, that's going to be the sum from I equal 1 to 6, f of, well, I have the starting side, -3, but I need to put the midpoint into the equation. And if I add 1, it's going to start at 1 of the delta x's. Now, see, what is delta x? So I go from -3 to 3, which is 6, divided by 6. Each one of these is 1 wide. So I'm going to start at -3. If I add 1 to that, I'd be at -2. I only want to be at -2.5. So what I do is I say I'm at -3, go back a half, and then jump 1, and I'll be at the midpoint. And then I plug all of that into f to get the height, and then take it times the width, which is the change in x is 1. So it's going to be 1 times everything. Well, that's not going to be exciting. And then I have to put each of these in, 1 through 6, in for the I, and plug those into the equation. So I'm going to have to find, if I put in 1 in the I, 1 times 1 is 1, and -3.5 plus 1 is -2.5. I need to find f of -2.5, and take that times 1, and also add to it. I'm going to do it at -1.5, so I'm going to have f of -1.5, and I'm going to have f of -0.5, then I'm going to have f of 0.5, and then I'm going to have plus f of 1.5 plus f of 2.5. I don't have my calculator. A little tricky to put those in for the x's here and figure out what f of it is, but that's what I would do. I put -2.5 in for the x's and figure out what it is. I would actually make a table. I made table start, make it be -2.5, and the change in the table should be each time I'm stepping up 1, and then I plug that in and plug into y1. I would plug in this equation, 4 minus x, close parentheses, divided by 1 plus x squared, all of that in parentheses. And then I would go to table, and it should give me all these values and more. But that's all I need is those, so then I'd add them up and take it times 1, and I'll figure out what they wanted me to figure out. Okay, so now they say find right 5. So sum from 1, I equal 1 to 5, and I'm going to do f Now if I'm going to be on the right side, I'm going to be at the starting place, which is -1, and then I don't have to back up to land on the midpoint or back up enough to land for the first jump to land on the left side. I'm just going to have to jump the width of the interval. So now see, what is the width of the interval? From -1 to 1, that's 2, or 1 minus a -1, 2, divided by how many times we're splitting it up? 5. So each jump is 2/5. So I'm going to go plus I times 2/5. So when I is 1, I'm going to be at -1 plus 2/5. That's on the right side of the first one. Then when I put in 2, it's going to be 4/5, the right side of the next one. Let me make sure I got that right, reading that 18. I'm looking at that 5. I thought it was 6, but I wrote down here. No, it's 5. So wherever this curve is, I have to start at -1. And then I got to go 2/5 over. And that's the right side. Then 2/5 over. And then 2/5 over. And then 2/5 over until I get to 1. Okay? And there should be 5 of them. 1, 2, and the third one would be somewhere here, and the fourth one, and the fifth one. So there's the height of each of these on the right side. And then I have to take it times the width, which is 2/5. And again, I could put the 2/5 on the outside, so I'm going to have 2/5 times. If I put in 1, I've got to find out what f of -1 plus 2/5 is -3/5, plus, then 2/5 more than that would be f of -1/5, plus, and then f of the next one up would be 2/5 more than -1/5 is +1/5. And then 2/5 more would be f of 3/5. And 2/5 more would be f of 5/5 or 1. So I got to put -3/5 in here and figure out what it is. -1/5, figure out what that is. 1/5 in, 3/5, and 1. Figure out each one of those numbers, multiplied by 2/5, and I'd have the right 5. 27. It says write this in summation notation. Well, this is 1, 2, 3, 2, 3, 4, 3, 4, 5. So it's n plus 1, n plus 2. So it's n, so I have I starting at 1 and going clear up to n. And I'm going to have, oops, not that there, just the line. It's got to be I when I is 1, and down here it's 1 more than I plus 1. And this one is 2 more than I plus 2. So when I put 1 in here, I get 2 here, 3 here, and 1 there. When I put 2 in, I get 2. 2 plus 1 is 3, and 2 plus 2 is 4. And it'll just keep going like this until I get to n, where I put n in, and that'd be n, and this would be n plus 1 and n plus 2. So there's the summation notation for that. Now 30, we're supposed to do this. Well, we're going to make j be 3 and then 4. So we're going to have sine of 3 pi over 2. That's what j is 3. And then we're going to go up 1, which should make it 4. So we're going to add. So we're going to have sine of 4 pi over 4. And the sine of 3 pi over 2, over 2, excuse me, 3 pi over 2, 1, 2, 3 pi, the sine there is negative 1. And the sign of 4 pi over 2. Pi over 2 once, 2, 3, 4. I'm there, which is 0. This comes out to be minus 1. The next one, I put in 3, and I get 3 minus 1 is 2, 1 over 2, so I get 1/2 when this is 3. Then I put in 4, 4 minus 1 is 3, so I get 1/3, plus, because sum, 1/3, plus, then I put in 5, 5 minus 1 is 4, so I get plus 1/4. Common denominator is 12, so I've got 6/12 plus 4/12 plus 3/12. That's 13/12. And this one, I put in 0. So I'm going to have 3 to the 0 minus 1 is minus 1. Plus, then I got to put in 1, so I'm going to have 3 to the 1 minus 1 is 0. Plus, then I got to put in 2. 2 minus 1 is 1. 3 to the 1. 3 to the minus 1 is 1/3. 3 to the 0 is 1. 3 to the 1 is 3. So I get 4 and 1/3. $36. So I'm supposed to add these up from 1 to 30. Now I can just put in 1, 2, 3, 4, 5, 6, 7, and all those numbers and figure them out. But I'm going to use some of those power rules that we know. Since we got two things subtracted, we can split this into two of them. From k starting to 1 to 30 of 4k minus the sum for k equal to 1 to 30 of negative 3 of 3. I put the minus out here, so that's 3. Okay. Now the 4 can be taken outside. So we can do 4 sum of k equal 1 to 30 of k. And we have a formula with the index is a variable and going 1 to something. There's a formula for that. And then this one's pretty easy. If we're going to go 1 to 30, there's going to be 30 k's. Every time it's 3 because there's no number here to k times it or anything. So we're going to have 3 30 times. So we're going to have 30 times 3, and we got to subtract that. Now the formula for just a single variable going from 1 to 30 is the variable, the end, 30, times 1 more than that, over 2. So that's how much that works out to be. It's n times n plus 1 over 2. It's a formula in the book. And we got to take that times 4, and then we got minus 90. So 4 divided by 2 is 2 times 30 is 60 times 31. Okay. Or 62 times 30, 186. I think that's 186 minus 90, which is 96, if I didn't make a mental arithmetic error on doing that. 39. 0 to 50. Well, if it was 1 to 50, we have formulas for 1 to 50, but 0 to 50 is a little different. So I'm going to put in the 0 and figure out what that is going to be. So 0 times 0 minus 1 is just 0. Plus, now I can do the sum as j goes from 1 to 50. Because I took care of j being 0. And this multiplies out to be j squared minus j. And so I can split this up into two intervals, j going from 1 to 50 of 1 minus 1 times j is minus j, and I've got the minus there. So I multiplied this out, got j squared minus j. I split this up into two, but I took care of j0 first so I can have j1. Now there's a formula for this one, for squared, and there's a formula for that one. So we have 0, which is nothing, plus the formula for the squared is the ending number. It's n cubed over 3 plus n squared over 2 plus n over 6. So I'm going to have 50 cubed over 3 plus 50 squared over 2 plus 50 over 6. That's what this one will be. Then if I go from 1 to 50 for just j, that formula again was n times n plus 1 over 2. So that's going to be minus 50 times 50 plus 1 over 2. And so all I have to do is figure out each of these numbers and I'll have my total. So I'd use a calculator at that point. Okay, now 42. This one, you could go ahead and put in 1 in here and square it and do all that. And that gets, you'd have 20 numbers. That's messy. We can also split this up. So first, let's square this. So 5 plus 3m over 2 times itself is 25 plus 15m over 2 plus 15m over 2 plus 9m squared over 4. So I multiplied first, outsides, insides, last. These are like terms and they add up to be 15m. So this is a summation from 1 to 20, but I can do each part separately. So I'd have, and 25, I can write 25, the sum from m starting at 1 and going to 20 of 1 plus, these two together are 15m, so I can write 15 sum from m starting at 1 and going to 20 of m, and there's a formula for that. And then we can go plus 9 fourths, the sum m starting at 1 and going to 20 of m squared, and this is a formula for squared. So, going 1 to 20, counting ones, that's 20 times 25. That's this one. Plus 15 times, for just a single letter, like up here, it's n times n plus 1 over 2. So it's going to be 20 times 21 over 2. That's what that is, times the 15. And then I've got to do plus 9 fourths. And the formula for the squared is this. So it's going to be, I'm going to 20, so it's going to be 20 cubed over 3 plus 20 squared over 2 plus 20 over 6. So if I work this expression out, I'll get the answer for this. Okay. 45. Now we're going to do pretty much the same thing, except we have to take the limit in the end. So I'm going to split this up. And I got an n cubed in the denominator, so I can take it out. So I'm going to have the limit as n approaches infinity of 1 over n cubed. Then I'm going to split the sum into 3 separate sums. The sum as I goes from 1 to n of I squared minus the sum as I goes from 1 to n of negative, and I've got the minus here, so of I, and then plus the sum as I goes from 1 to n of 1. So I have the limit as n goes to infinity of 1 over n to the third. The squared one, again, from the formula in the book, it's n to the third, the top number to the third, over 3 plus the top number squared over 2 plus the top number over 6. That's what this one would be. Now I got to subtract this one, and when it's I, it's n times n plus 1 over 2, and I've got to subtract all that, plus, and then 1 to n, adding 1, so that's n ones, which is just n. So, thinking this out a little bit, this is minus n squared over 2 minus n times 1, n over 2. That's what this is. So, what do we have? We have the limit as n approaches infinity of 1 over n to the third times n to the third over 3. That's the only term that has n to the third. N to the second, I have n to the second half of it minus half of it, so those cancel out, and there's no more n squareds, so those are gone. Then I have a sixth of n minus a half plus 1. So I have 1 and a sixth minus a half. 1 and a sixth is 7 sixths n minus a half, which is 3 sixths n. So I end up with 4 sixths n, or 2/3 n. So I have, for the n's, I have plus 2n over 3. Now if I distribute this back in, I get the limit as n goes to infinity of the n cubes cancel, and I get 1/3, plus, if I take this in here, one of the n's cancel, so I get 2 over 3n squared. And when n gets very large, this fraction goes to 0, and the only thing I'd have left is 1/3. And finally, 48. Nope, 48 and then 52. So now I'm supposed to do the right of 3x plus 6. So I'll make it a nice big graph so we can see it here. That's crossing at 6. 1, 2, 3, 4, 5, 6. And has a slope of 3. So it's a pretty steep graph. 7, 8, 9. That's 1. 10, 11, 12. That's at 2. And I'm supposed to go clear out the 4, so that goes out here a ways. And we're supposed to do the right side. And we're supposed to do as n goes to infinity. So we're going to start splitting this into n rectangles. So I'm just going to draw some here and know that there are going to be more and more and more of them. So how wide is each one of these going to be? Well, if it goes from 1, I'm supposed to do from 1 to 4, so I didn't set this first one up right. That's a, excuse me, a total width of 3. So each one of these, if I split it into n pieces, each one is going to be 3 divided by n wide. So that's the change in x for each one of them. Okay? Now, we're supposed to do the right side. So I don't want to start at 1. I want to go to the right side of that first one. So I want to jump 1. So I'm going to have the limit as n goes to infinity of the sum I starting at 1 and going to n, because I'm going to have n of them. And I have to do f of the right side. So that's going to be starting at 1, but jump over a change in the interval of 3 over n. And I'm going to do that once. Then I'm going to jump 2 times, then 3 times, and then 4 times. I'm going to keep adding delta n's. So I'm going to plug those into this equation. And that'll be the heights at the right side. And I got to take them times the width, which is 3 over n. So what does this become? Well, this is the limit as n goes to infinity of sum from I starting at 1 to n. I can take the 3 over n and factor it out. And now I got to plug this into my equation. So it's going to be, this is the x. I put it in for the x. So I'm going to have 3 times 1 plus 3 over n I, 3x plus 6. So that's plugging this into f. Now I got to find this sum. So I'm going to simplify this. So this is going to be 3 plus 9i over n plus 6. So I'm going to have the limit as n goes from to infinity of 3 over n sum I from 1 to n of 3 plus 6 is 9 plus 9 over n I. Now I'm going to use formulas on these. So I'm going to have the limit as n goes to infinity of 3 over n, and I'm going to split these up. The first one is going to be 9 times the sum as n goes from, or I goes from 1 to n of 1. 9 times 1 is the 9. And that's going to be just n. And 1's added is n. Plus, I'm going to factor out the 9 over n. And I'm going to have the sum as I goes from 1 to n of I. And we have a formula for this. So we get the limit as n goes to infinity of 3 over n, 1 to n ones, that's n number of ones, which is n times 9, so that's 9n, plus, and the sum of I, as I goes from 1 to n, is n times n plus 1 over 2, and that's times 9 over n. this n would cancel. And so now I will simplify this. So it's 9n plus 9n over 2 plus 9 over 2. And that's all times 3 over n. Okay? So 9n plus 4.5 n's is 13.5 n. So I've got the limit as n goes to infinity of 3 over n times 9 plus 4.5, 13.5 n plus 9 halves, or 4.5. Now if I distribute this in, I'm going to get 13.5 times 3, that's 3940.5. When I take this times this, the ends would cancel. Then this times this is going to be 27 over 2n. And I have to take the limit as n goes to infinity of this. Well, as it goes to infinity, this goes to 0, and the limit as of 40.5 is 40.5. Okay, and finally, the last one, 52. So we're doing 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 is the y-intercept. Minus 4. 1, 2, 3, 4 for 1. And again, and again, as we go from 2 to 6. So the 6 is way down. That's going to be way down there. Two, 3, 4, 5, 6. And we're supposed to do the midpoint. Make sure I got that written down right. Quick check. 52. Yeah. Okay, so to do the midpoint, it's going to be a sum, and we're going to do infinite number of these. So it's going to start out with n of them, 1 to n. And we got to do f, the height of them, at the midpoints. So if I start splitting these up, to get to the midpoint, I'm going to go to 2, go back half a change, and then jump a whole change to be at the midpoint, and jump a whole change to be at the midpoint again. So I have to go f of the beginning place, which is 2, back a half of width. Well, from 2 to 6 is 4, and I'm splitting this n times. So that's the width of a full one. So a half one is 2 over n. So I'm going to start at 2, jump back a half a width, which is 2 over n, and then I'm going to start jumping full widths, plus 4 over n I. And then I've got, that's the height at the midpoints, and I got to take it times the width of each of these, which is 4 over n. Okay, so that's set up. Now we have to work this out. So we get the limit as n goes to infinity Put the 4 over n outside it. Sum as I goes from 1 to n. Now I got to put all of this into f. Well, let's simplify this first. So we have 2 minus 2 over n. That can't be simplified. It's not times I, so we're kind of stuck with what we got. So we're going to put all of that into here. So we're going to have 12 minus 4 times x. And x is going to be all of that. 2 minus 2 over n plus 4 over n I. That's what I'm putting in for x. And it's 4 times that, and then 12. Okay, so we got the limit as n goes to infinity. 4 over n, that's the width of the intervals, times the heights. I'm going to split this up, but maybe I can simplify this a little bit. So I'm going to have 12 minus 4 times 2 is minus 8. Minus 4 times minus 2 is plus 8 over n. Minus 4 times 4 over n is going to be minus 16 over n I, which is going to be 12 minus 8 is 4, plus 8 over n minus 16 over n I. Okay. Now we're going to split this up into 3 different ones. So we have the limit as n goes to infinity of 4 over n. The sum of this first one, 4, sum of as I goes from 1 to n of 1. Once again, that's n ones added, so this is just n times 4, plus the sum as I goes from 1 to n of 8 over n. There's no I, so I can take all that out, 8 over n times 1. And so this is just n, minus 16 over n times the sum as I goes from 1 to n of I. And we have a formula for that. So we get the limit as n goes to infinity of 4 over n times 4n plus this is n times 8 divided by n, so that's just going to be 8. This is n divided by n, minus this is going to be, see, we got 16 over n times I is n times n plus 1 over 2. So this n will cancel that n, and 16 divided by 2 is 8. So I'm going to have 4n plus 8 minus 8 times n, which is minus 8n. Then I'm going to have minus 8 times 1, which is minus 8. And these will cancel. I'm going to 4n minus 8n, which is minus 4n. So we're going to have the limit as n goes to infinity of 4 over n times negative 4n. Those cancel, and that's that. So And these n's cancel, so I've got now negative limit as n goes to infinity of negative 16, which is just negative 16. Now, how can the area be negative? Well, we got some positive area and we got a lot of negative area, making the total area negative. We could actually figure this out. At 2, negative 8, 4 times 2 is negative 8, so this is at a height of 4. And 2, and when we put in 3, we're at 0. So 1 wide, 4 high. The area of this is 1 times 4 cut in half, which is 2. A plus 2. Now this part, from 3 to 6, 6 in here, that's 12 minus 24, which is minus 12. So we got 12 times 3, which is 36, half of that, which is 18. And this is minus because it's below the x-axis. So we got plus 2 minus 18, which is minus 16. Okay, and that's that.